This is masses of gases lab. In this lab, you will understand the how to graph the graphing technique, and the how do you interpret once you plot a graph using given set of data, how to interpret the graph. And also you will understand the relationship between volume of a gas and the molar mass. So we have the law, we're doing that, basically the relationship is Avogadro's law. So in the lab, starting with the showing you the simulation, how to fill the gas and evacuation, and then you go to the part two. Part two, starting the collecting and interpreting data of these gases: nitrogen, butane, carbon dioxide, argon. So first thing is you need to know how to find the molar mass of each gas. So what is the molar mass? In order to find the molar mass, let me open my thing. Uh, let me show you example first how to find the molar mass of gas. So I can see here you have nitrogen N2. So in nitrogen, you what is the how do you find the molar mass? You can look at the periodic table and get the atomic mass of nitrogen, and then you multiply in two times. Example, let's take carbon dioxide. CO2. How to find the molar mass? What is the mass of carbon dioxide? It's in your periodic table, mass of carbon dioxide. If you look at the periodic table has listed the molar masses of each and every element. You do not have to memorize it. Look at the periodic table, get the mass of each atom. Carbon dioxide, which comes as 12, and oxygen is 16, and into 2, because you have two oxygens. So then you can add all these numbers and it come to 44. So molar mass of um, carbon dioxide is 44. Similarly, let's go to nitrogen. Nitrogen is um, uh, so it's 14. 14 into 2, it's gonna be 28, and then C4H10, um, which is 12 into 4 plus hydrogen is 1 into 10, right? So 12 into 4, it's 48, plus 10, it's going to be 58. Like that. Then argon, you don't have to calculate it, just get the value from the periodic table. Like that, you have to find the molar mass. So first thing is finding the molar mass. And then when you find the molar mass, you have to uh, look at this each gas. You can run the simulation for each and every gas. So when you run it, you can get, okay, this is, already molar mass you calculated, and then from the simulation you can get the mass of a 1 liter of a gas. So you calculate the molar mass for each gas. Nitrogen, argon, you don't have to calculate because you can directly get from the periodic table. Butane, and then carbon dioxide, oxygen, R134A. You go up and see what is this R134A. R1, it's a C2H4F4. Just don't worry about the like the complicated name. It's just C2, so two 12s, two, one hydrogen is one, and the fluorine into 4 times. And once you get the molar mass for all the gases, so this is, you have it, okay. And then the mass of 1 liter. Mass of 1 liter you get from the simulation. And once you have all the data, you go plotting the graph. So let's see, how do you plot this graph? It is mass per 1 liter in molar mass. So you put the molar mass in this y-axis. Then mass of 1 liter. I think you will get a graph. Let me go up here. Get a graph like a straight line. Okay, I can't draw it. And then you get a graph like a straight line. Okay. So when you get the so you get when you get the graph, I just did the arbitrary line. Okay, you have to go with the your exact data sets, but I'm just drawing the arbitrary line. And then there are some questions. So let's see what are the questions they are asking. So their first question is oh, which of the following describe the pattern? And then I wanted to show some items. Click the linear regression button lower at the left of the graph. Below the linear regression, you will see the equation. So y equals mx plus c. But instead of y and x, you will see the quantities you graphed, molar mass 1 liter. Notice that m is the slope. You will see, so then you have to find what is the m. So it's very important you get the correct m value. I'm just taking according to my data, I get 0.042. So, and then they have another question. What are the correct units, not simplified, for the slope you have found? So look very carefully at the unit of your axis. So then, what is the what do you think? So first I plot between the slope is between basically m is y. See, this is the m. This is the m. M is y divided by x. So what is my x-axis? What is my y-axis? Mass for 1 liter. So mass per 1 liter. Mass is in grams per liter. So grams divided by liter, and my molar mass is grams per mole. So what is the unit of, not simplified units of the m? Let me show you. Let me take the thing. Okay, so give me a minute. Let me draw for you. So my m, you saw here, y equals mx, right? And c also there, but basically m is y-axis divided by x-axis. So what is my y-axis is mass per liter, gram per liter, divide molar mass. Unit of a molar mass, grams per mole. So divide by grams per mole. So this is the what is the answer that question is asking. So these are the units of your m, and then they ask you to simplify it. Let's see, how can I simplify that? Grams per liter divide grams per mole. You know, when there is a division sign, you can proceed. This is math now. So grams per liter, in order to get rid of this one, you put the multiplication, but this second denominator, mole goes up, gram goes down. Grams, when you'd have this, take another color. What I did, I changed the sign of the division to multiplication. In order to change the sign of the multiplication, I have to switch this. Moles goes up, grams go down. Okay. And then I have this one. I ended up with this one. And then, uh, so now what I can do, because you see grams, grams, I can cancel. But I cannot cancel moles per liter. So I ended up with, when I simplify, moles per liter. These are the units for the M. Moles per liter. Okay. Okay. Let me escape this. Okay. That's good. So moles per liter. So I go down. So we figure it out. This one grams per liter, grams per mole, and then okay, we get okay, it's moles per liter. And then now I think you are capable of doing it. They ask you will see when you do the sections, you can come to the next section without completing the simulation. Um, if you found the slope is 0.042, um, so how so that means we found it's the units are moles per liter. So every liter has 0.042 moles. That's what it means. Okay. And then you found, that's another thing I want to show you. Let me write it down. So they said 0.042, you get 0.042 moles per liter. So now they are asking if it is, what is it, what if it is liters, we call liters per mole. But if you switch it, switch the units, what do you mean by the switching the units? Now, if instead of this one, if I have the liters per mole, so in any way, when you have this kind of a thing, there's arbitrary one here, right? We don't write it, the one. So now if I change upside down the units, I have to change these two numbers also. So basically what I do, I take one up, 0.042. So if you have a calculator, let me use my calculator. 1 divided by 1 divided by 0.042. 1 divided by, it gives me 23.8. Okay, so 23.8, it's almost like 24. So you get so this is how you just in this lab, it's basically the important thing is you plot the graph, you find the molar mass. um, then we have like very basic gases. To find the molar mass, you try to find the molar mass. You can do the calculation, and when you do the calculation, you can check in the internet too. Okay, is this the molar mass of nitrogen? But you can, if you have the periodic table in front of you, it's very easy. Like you can look at the periodic table, get the atomic mass. If it is 2 nitrogen, multiply by 2. And if you have many, you just add all the atoms. When you do the let me go up. When you do the um, molar mass, and then you run each simulation for each gas, and you fill the moles per liter, and then you plot the graph between. So you already have these two variables, and then you plot the graph. When you plot the graph, you have to come up with the units for the slope. Mass for 1 liter. Mass is in grams, liter also grams per gram divided by L. Molar mass is grams per mole. That is the units for the molar mass. I know this is little bit, no, it's molar mass is grams per mole. And then you can get the simplest, first you get the M, some value, you have to come up with the value, and then you have to come up to the unit for your M, And then you simplify your unit and then go from there. Okay. And that's how you do it. And that's oh, then there's one more thing. Another experiment conducted uh, under identical conditions with mystery gas. The scale reads 0. So that means what is this? Scale read the mass, right? So the scale read the mass for the 1 liter of gas. Excuse me. So the then using the slope, you already know the slope. I'm using um 0.042 as my slope. So that is m. We know we learn from m equals y divided by x. And then what is the mass, which is 0. So m I already know 0.042 and my y 0.165. No, I can write it here. 0. Okay. So my 0.042 equals y 0.165 x. I have to find the molar mass. Molar mass comes to the x. So my x is so in this kind of a calculation, I can take my x to the up, okay, and then so basically how I take the x to the up, I multiply both sides of the x, so this x cancel and x goes here, and then I can take the 0.42 down, 0.165 divide 0.042, and then you can find in this way, you can find the x value, which is the molar mass, and then go to the periodic table and see which one is the closest molar mass to this number. It can be 8, or it can be 7. Like if it is like um 8, it is like so what is it? Try to find it. It's for you, and you get uh try to go with the closest number. Okay. So when you get the number, make sure you round off the number, and then find the closest one. So I hope this video will help you to understand the lab.